Hi, we're also going to be live coding, but we're also going to make you look at slides too. So,
yeah, so hi, I'm Lisa.
Hi, I'm Gina. And we, as Brandon said, we're native mobile engineers at Kickstarter, and we wanted to share with you how we find functional reactive programming to be really powerful and fun, and when we apply it with a model view model architecture and a TDD or test-driven development style.
So by now we all know that function programming is fresh, but why should we use it in our daily lives? And especially if we're on a team of junior to senior engineers, there's a pretty big startup cost in forgetting all of our imperative coding and going functional.
That's a great question, Lisa. We found that we've made our lives as a whole team a lot easier and our code a lot safer and stronger by adopting an MVVM, model view model architecture that separates our logic from our view controllers and for easy testing. The basic setup is that our view model acts as the brains containing the pure logic behind the view controller. The view controller simply sends data to the view model and blindly sends data and blindly takes data that's emitted by the view model. The view model then just takes all the inputs that it receives and figures out what to do with that data. Now, when I say view controller, I also mean any kind of view. So, for example, we sometimes find that a table view cell or a collection view cell can be very complex with logic, and we'll give it its own view model as well. Right. So we use the Reactive Cocoa framework for iOS, and we use RxJava for Android, both of which are based on the paradigm of observing signals that emit values of data over time. And because they rely on the same concepts, we've been able to build a similar architecture wherein the view controller remains really lightweight without any logical responsibility, and it simply reacts to stateless and immutable values that are emitted by signals that are outputs from our view models. And to Lisa's point, in this way, no matter what level our engineers are at or what platform they're coming from, we found that they can pop into the code and get up to speed really quickly and find it really easy to read. So, aside from being really easy to read and being highly organized, the real beauty of separating our logic or isolating our logic in this way is that we just run all of our tests on the view models. So, in fact, we don't commit any code or commit any of our view models to master without sufficient and reliable tests. And we try for 98 to 100% coverage on all of them. We don't always get that because we don't have a lot of time, but we try for it, and we're actually up to 764 tests, which is kind of amazing if you think about it. And I think it really speaks to how easy it is to create tests with this architecture. So why do we love tests so much? Ultimately, they give us the confidence that our code is really strong and that it's as fail-proof as we can make it. I find where it really shines and where it's really invaluable is when we go in to refactor something, or another developer who has never touched the code before comes in and starts messing with it, and then we have the test to back us up and ensure that we still get the same behavior that we expect. And that's been pretty amazing because that happens all the time, that we break stuff, and we have tests to confirm that, so it's great. We also can test edge cases that may be really difficult or impossible if we were just testing on the views themselves. And lastly, tests can actually feel like a game if your goal is to get 100% coverage on the view model. So especially if you're using a TDD style where you're writing the tests first, you get this little rush of dopamine when you start implementing the logic and then your tests pass. So, yeah. Oh, whoops, sorry.
Well, speaking of fun games, Gina, I'm going to try and clip this onto myself because I can't hold it. Sorry.
All right, now you have the basic
Can you
idea.
hear me? Okay. So speaking of fun games, Gina, there's this fun game that I wrote before I joined Kickstarter. Let's run it. And I had a bunch of notes, but I forgot them, so bear with me. But now you know that I'm doing this for real, and I'm really legit. So let's check out this game. That's really fun. So before I put that on the App Store, I want to try out some of the stuff that Gina was talking about. And this is my view controller. And since I worked on it before Kickstarter, it's pretty stateful and it's pretty basic. So let's start making this functional by creating a view model. Luckily, I already have one created. And can you all see the code? Would it be better if I changed the, yeah, that's fine? Okay, whatever. So you can see in our view model that we have a couple of protocols defining inputs and outputs that a view model class extends. So they have to conform to them with an initializer. Let's even take this one step further because we are in functional Swift conference, and this is, yeah, and this is good. So we'll make a type that this view model also has to conform to. And what this does is it only allows us to access our inputs and outputs via our view model. So there's no rogue getting any of our inputs and outputs without going directly through this view model. So cool. Let's conform to that. So make this happy. And I'm going to scoot this over because we don't really care about it that much. Sorry, it's really ugly. So yeah, let's actually, no, we do care about it. So let's look at our game. So let's look at our game again and look at the UI elements we have to see how the gameplay sort of works, because it's really complicated. There's an action button that we see is funneled through this IB action that just calls this big function called play game, and what it does is increment the score that is mutating score variable to set the string to your score and change the image. Cool. So why don't we start first then by making that, input, which is when the action button is tapped. And since we have to conform to our view model inputs, we can go ahead and define this property. So what's going on here is we're using a mutable property, which is what takes the action button, the input from the action button, and turns it into a signal. And we can use that signal in the view model to do whatever logic we need. And it's void because we're not passing in any value from the action button. So let's move on to our outputs. We can start with the simpler one, which is the score label, because it's 1-to-1 and it just increments every time it's pressed. So we can go ahead and make an output, which is the signal of the score label text. We like to be really explicit here with exactly what we're doing. And now that we have the score label text, we can go ahead and set it and make it .empty for now so our compiler is happy. And also make it a let because we do not want that to mutate. And while we're there, we'll also go ahead and make the image name for the image that we'll want to display when we do that. when we, for the image we want to display. That's pretty cool. So that was pretty fast. And we have all the inputs and outputs we want to define set up. But because we want to stick as much as we can to being very good test-driven developers, let's make a test before we write any logic. How many of you in here think testing is important? So how many of you actually write tests in your apps? Oh, that's pretty good. That side's better than this side. All right, so here we have scaffolded a viewModel test, which extends from the built-in XC test case of iOS. Oh, by the way, I'm using reactive Cocoa. Oh, also it's Swift too. Sorry. But, yeah. So we have our viewModels defined with the type and the viewModel, and because it's an XC test case, we have the usual setup and tear down functions overridden. You see this app environment thing going on. I'll go into that a little bit later. Don't worry about it right now. So let's start writing a test. Let's say start with a score label let's start with the score label. So to do that, we have something called a test observer. And I'll go into that in 1 second after I finish typing. Cool. So let's actually take a peek into our test observer. Shout out to Brandon, who actually wrote this. But this is the actual test observer class. I'll just leave this up so you can read it if you want. It's a test observer class that is a helper class that transforms signals and does a lot of functions on them, and basically gives us an access to an array of events and an observer that allows us to test on a history of the events. So we'll be using this within our test file. So we'll make one for score label test, and while we're at it, I have shortcuts. We'll make the image name as well. And how do we listen to the viewModel outputs from this different test file? Well, it's pretty simple. We can just observe on those. And autocomplete is pretty nice to me today. So we'll just go ahead and set this up so I won't forget, because I always forget. And cool, so now these test observers are live, and we can just start writing our test. So we'll just call it test game. And let's think about what happens. So every time we press or tap our action button, we expect our score label to increment by 1. And let's make this test a little bit better and know the next time it's tapped, we expect the score label to emit 2. And what this 1 that we keep here is for is, as I mentioned, it's a history of the events that happen, so we can get a full timeline of everything that happens. It can get a little verbose, but it's really good. It's really helpful in production. So let's go ahead and just run this test, because why not? It failed, obviously, because there's no logic written yet, duh. And we can see that nothing was emitted because this is an empty signal, and this is good because we know now that going forward with this test, we're not going to get any false positives. There are no magic tricks happening here. It's just whatever is happening in the viewModel is going to be reflected correctly in our test. Awesome. So with that, I'll just close this. Oh, you didn't see that. It's not that, okay. So with this, we can let's start writing our logic for the score label. If we remember from our view controller, there's this really annoying score global variable that's mutating, and it's just everything that we don't like because of what I just said. And let's replicate what happens. Every time that we tap the action button, it increments by 1. So for the score, let's just make it every time the action button is tapped, we take that signal, and we can use this nifty scan function that's built right into Reactive Cocoa, accumulate on the initial value of 0, and increment it by 1. So the second value is void because we're not passing, the signal itself is void, and we're not passing any value through. So you can imagine that if we had some values that we want to work with in production, like we can get really fancy with these functions. So now let's hook it up. It's as simple as taking the score, mapping it as a string because we're going to display it as a UI element. Oops. Okay. And that's it. And of course, we have to get rid of this because we don't want to initialize it twice. And now we're ready to hop back to our tests. Let's run this file again. Great. So even if you didn't really know that function, if you didn't get it right now, or if you don't trust me, like, now you know it sort of works. I can even go and like make it 3. Why don't we? Because it's really fun. And just run it, just so you know. Awesome. So we're feeling more confident about our code. Okay. So let's just finish this, or let's hook up the second output. So we have an image name left. And if you look back at the view controller, within this, there is a little switch case statement that basically counts taps and returns these UI image names. And what I had before that maybe you peeked was this helper file that I just pulled. I pulled from the view controller called image name 4, and you can see it's the same, except this time instead of using a global variable, we pass in the count and we return the name of the image. So that's pretty cool. All we need to do now is, again, take the score and map it into our private function. And we can even take it a step further and get really cool and go point free to make our code nice, and just map it onto the image name for score. It's really readable, really beautiful. Awesome. So let's go back again, since we're doing TDD like good people. Let's go ahead and test on these image names. So I think it was happy, and then it was tapped again, and it might have been happy again, and then, well, whatever. And then happy, maybe it went to content. I'm not really sure, but let's just run it. Oh, nope, I was totally wrong. So it actually went from happy, happy to happy because I have a really bad memory, and it's from 0 to 3 that's happy, but our test caught that. Good job, test. All right, so so let's run it again. There we go. So what else can we do? I know. Let's talk business. So sometimes our PM tells us that we care about what users do with our apps. That's fine. We have this tracking client called Panda, obviously. That's the name of our tracking client. That tracks whenever the button is tapped. And what you need to know about this app environment, it's basically just this global stack of values that saves global values of what we want to know about our app at the time. And we can just observe next on the signal and invoke this function. So to get more into that in the tests, we can see that this is where we get back into the app environment. And let's do something nifty here, make a mock tracking client, and then within pushing our environment, setting our test environment, we'll push the Panda tracking client with this tracking client, which is a mock tracking client. So it's important to note here that Panda is essentially a wrapper around a tracking client. And the tracking client we pass in usually sends to the server, but in a test case, because it's a mock tracking client, it just saves those events to an array that we can test on. So what does this mean? This means that every time the button is tapped, we can tracking client dot events. We can make sure that our tracking events are happening as we expect. And I know that this is button press because within our Panda, this is the event name that tracks. Our test would have caught that too. All right, so why don't we do that for everyone? Because sometimes we care if there are multiple taps, maybe we don't, but let's just do it for the first two. Pretty neat. So now we can make our PMs happy and make confident business decisions because we know all of our events are being tracked correctly. And also that was super lightweight. We just added it without even making an output. Although there's more going on in the background. We'll go into that later. It was just super easy. So let's keep going. Let's see what else we can add. Let's add some accessibility. So we know with the label, the score in the top right corner, it's just numbers. And if a user can't see the screen or doesn't want to look at the screen, we want to make sure that it has enough context. So a label will make a new output for the scores accessibility label. I'm just going to abbreviate for now, which will be a string that the screen reader reads. And we'll just add that. Again, make sure it is immutable. And why don't we just make that something like, oops. Maybe let's just use a score, and every time we can map that value onto a string that says something like, your current score is that score, just something simple. So now we have that accessibility element as a simple output as we've done before, which means, you guessed it, we can write a test by making a test observer. That's the score accessibility label. Make sure we hook that up. And let's just go ahead and make a new test because this test is getting kind of long. And I made a shortcut for that, so it's the same. When the action button is tapped, we can emit the accessibility label, which the first time it's tapped, we know that it'll say the current score is 1. Let's test that. All right, neat. So now we have a pretty solid view model with all of the logic that we wanted from the beginning and tests to back that up. And we haven't even run the simulator yet. All that's left to do right now is to go to our view controller and make it beautiful. So we can begin doing that by removing all of the state and all of the logic, which is what we wanted, as Gina mentioned before. So we can begin by getting rid of this global variable, by getting rid of all of the logic in our game, and replace this by making our view model, again, conforming to its type. And this doesn't exist anymore, but instead of calling a function every time we call the button, we can just invoke our view model. And then with all of our outputs, we can just bind everything. And this is, again, where the type really helps us, because we know that via our outputs, we just have these 3 things that are pretty descriptive that we know exactly what we want to do. So let's begin with our image name and just observe next. Have a weak reference to our stuff for the UI. We can just take the image view, of course, this is optional. I think I did something. Ooh. Thanks. Is a UI image named the image name. That's pretty neat. And something to note is in production, of course, we would want to observe on the UI thread, but since this is a demo and it's pretty simple and nothing crazy is happening in the background, we can just get away with observing next. And that's pretty cool. We can go ahead and finish binding all of our other outputs. Yeah, okay. I'll just copy and paste because I forgot my shortcut. But we can just use this as a guide. We have score accessibility label, which we know is a string. So we can just self.score label. Accessibility label, which all of these accessibility elements are already built into Swift. And then finally, we can take the score label text and take the score label again. And set the text. Neato, that was pretty fun. So let's run this and see if it works. Normally in demos, I'm very worried because nothing ever works the first time you run it. But because we wrote all those tests, it works exactly as we expected. And then if we want to take a peek at the accessibility inspector, we can look at this label and we can see that our current score reflects what should be happening. Or it reflects what we wrote in, so it gives you a little more context. That's how you use functional programming in your daily life.
We're not done. We have like 30 more seconds. Oh, sorry. All right, that was awesome, Lisa. Hopefully we've shown you how fun and powerful functional reactive programming can be in the MVVM and TDD flow, and that tests are not only important, but they can also be fun and really easy to implement. Even though Lisa's example was kind of oversimplified, it actually is very fully representative of the architecture that we use throughout our entire native code base. And it, okay, forgetting everything. Really illustrates like the process that we use every single day. So we hope that it inspires you to try it out, and if you have any questions or want to discuss it with us, we're available after at all the breaks and also tomorrow morning at the unconference portion. So, oh yeah, and this, thank you.
Nice to know.
Yeah.